Hey everyone, welcome back to this course. Today I just want to go over some of the assignments for your first lab meeting. So here I am on the Canvas page. Under Module 1, you'll find the Week 1 agenda and the assignment. It's called the Light Show. And you can just click on this and we can pull up the assignment. So as part of this assignment, you'll be submitting a lab notebook. This lab notebook you'll be building on for the rest of the quarter. So we can just maybe make a digital notebook. I'd recommend using Google Drive and just setting up a Google Doc to do this lab notebook. Right, so notebook entries should be organized by week, and you are to include answers to the exploration, pictures of your setup, meaningful discussion, and concluding remarks. So the idea here is that someone should be able to pick up your notebook and understand what's going on, what you've been doing for the most part. So here's the assignment itself, right? And we can go ahead and I'll show you how to kind of set up your lab notebook. So nice thing about Google Docs, right, is that you can insert headers. So we have a title called E151 lab notebook, and you should include this is Cal Poly San Luis Obispo, have your name, instructor, term, and maybe just like a date, revision date. So whenever you make updates to change that revision date. And you're free to format this title page however you want. But on the next page, oh, we're already not there yet. Okay, so on the next page, you should have a table of contents, and you can have one that automatically updates by going to Insert, down here, Table of Contents, choose whichever one you want, right? And there's our table of contents. So here, level 2 header, table of contents. And now it's pretty much set up how we want it. So looking at this assignment, you're gonna have to answer the exploration questions, over base functionality, should demonstrate that. And there's also extra functionality, which isn't required, but I think it's kind of important to reinforce some concepts that you'll be learning in the future. So looking at this exploration, these questions are pretty open-ended. You're free to use whatever resources you want to answer them. For example, here we're talking about describing the parts of a breadboard. You can Google breadboard and come to some kind of conclusion on how they work. Some of the questions specify where you should be looking up answers. So here, this is how many pins does your Arduino board have? And you use the Arduino hardware page. So if I just go to Google Arduino hardware page, or just Arduino hardware, first thing that pops up is this page. And you should be able to find your board under this classic family section. I know I mentioned using this Arduino Mega, so you click here, don't worry about that. Scroll down to the technical specifications and kind of just locate how many pins, digital pins, right, that your Arduino has. So that's pretty straightforward. Again, here, when we're talking about functions, we want to reference this Arduino reference web page. So Arduino reference, pull it up here, and it gives you a list of all the functions that are kind of built in to Arduino, which is nice. This last question is kind of interesting. Main thing to pay attention to is that we are supplying a constant voltage. So this V is held constant, and we're asking what we can do to reduce the current. It should be pretty straightforward, hopefully. And if we go here, right, so back in our lab notebook, we can say level 2 header, maybe lab, week 1 lab. And then you just talk about introduction, pictures of setup, etc. And then here we have your base functionality, maybe it's like level 3, base functionality. Maybe here you want pictures of setup. Under this lab, you just talk about what's going on. And then extra functionality, we should talk about some of these items here. So it says the first part is to create a function for a 2-bit up counter that changes state every 100 milliseconds. So this 100 milliseconds can be implemented just using a delay function. Look into that. So a 2-bit up counter, right? Let's talk about that. So this is how we count: 0, 1, 2, all the way up to say 9, right? And then we move it over to 1, 0. So that's 10, 11, 12. It's a similar idea with binary. So right, this is a decimal count, kind of a binary count: 0, 1, 1, 0, 1, 1, right? So it's kind of like a similar idea here, where we kind of just push over the next digit once we run out of representations of our number, right? So in binary, we call this base 2 because there are only 2 values that the character can represent. Whereas in decimal, we have 0 to 9. That's called base 10 because there are those 10 values, that 10 different characters that we can use to encode a number. So the idea behind a binary 2-bit counter, right, is going to be, suppose we have our 2 LEDs. Say LED off, we encode this as a 0. LED on, we encode this as a 1. So then we can begin to construct this counting sequence: 0, 0, 0, 1, 1, 0, 1, 1, right? And we should be able to kind of create this 2-bit up counter using LEDs, and it should go through this exact sequence, right? And that's kind of the idea behind this first step under extra functionality. And the second step, I'll help go through this first example. So suppose we encode LED on as true and LED off as false. Then we can begin to construct these logic gates, right? So what we usually do is we create a table. Right, so here we have bit 1, bit 2, and our first gate here is an AND gate. So an AND gate, the output is true when both of the input bits are true. Right, so we do a bit 1 and bit 2, and we begin to construct this truth table, is what we call it. And the easiest way to do this is kind of just have this up count. Right, start off with this 2-bit counting sequence. So 0, 1, 2, and 3. And then we look at the truth values of bit 1 and bit 2. So these are both false. So this is false. Only one of these are true, so this is still false. Same idea as this step. And then this only bit 1 and bit 2 are finally true, so we can say this is true. And again, this is called truth. Let's say 2-bit and gate truth table. All right. So in your lab notebook, you should go through and kind of create all these truth tables and then try to see if you can implement this using your Arduino, all these different gates and or XOR, NAND, NOR. All right, and then for this last bit of extra functionality, we have a couple clock signals and a data signal. So we have clock 1 with a period of 100 milliseconds, clock 2 with a period of 400 milliseconds, and you're monitoring a data line that changes every 500 milliseconds, and it randomly changes. So we don't know what the state is or what the state's going to be, but we know that it has the potential to change every 500 milliseconds. So we can use an AND gate to pull the data, right? So we on the up, when bit 1, right, of our clock, or when our clock 1 is high, we're pulling the data. We're seeing what's on this data line, because if the data line is high and the clock line is high, then we see that the output of that AND gate is going to be high, right? And then same idea with this clock 2. We pull the data. If the clock is high, but like the data is low, then that's going to be low. And the idea here is we're using an XOR gate to compare the pulled samples, right? So you'll get to this, but it's only the output of an XOR gate is true only when one of the bits are true. So we can use this to compare 2 bits, basically. And then kind of just explain how this relates to the Nyquist-Shannon sampling theorem. For that, you should probably look it up. But the idea is you have to sample at least twice the highest frequency present in your data, right? So frequency is the inverse of period, as some of you may be familiar, but basically our data signal has a period of 500 milliseconds, more or less. So you kind of need to find which of these clock signals you should be using to pull the data. And if you implement this correctly, you should find that these 2 values, exclusive ORed with each other, will have some difference. Will be true at some point, which means that there will be some differences in your samples. So that might be a lot. Take some time to review this if you get a chance. Otherwise, I mean, we're going to be doing it the first day. And again, all you're required to do is this first part, base functionality, just creating a light sequence that uses the delay function. But that concludes what I had for this first meeting. So I'll see you guys next time. And thanks for watching.